following statements about f of x equals x squared minus 9 in the numerator, x minus 3 in parentheses squared times x plus 5 in the denominator is false. They want the lie. So it's like 3 truths and a lie, the game that you played in high school. I didn't because I didn't have friends. This is what we're looking at. We're looking at a rational function. The bottom is factor, the denominator is factor, the top is not. So let's factor out the numerator. X squared minus 9 is a difference of squares. X squared minus 3 squared. So you become x plus 3, x minus 3, like so. The denominator does not change. X minus 3 in parentheses squared, x plus 5. Okay. Now, again, we're looking at, just briefly zooming through this, we're looking at magic words like vertical asymptotes and zeros and wholes. So what we need to do is we need to pretend that each of these factors are set equal to 0 and figure out their magic numbers. For example, if x plus 3 was equal to 0, you subtract 3 and negative 3 is your magic number. Positive 3 is your magic number. Positive 3 is your magic number. Negative 5 is your magic number. Now, when we're dealing with rational functions, we're dealing with vertical asymptotes, wholes, and zeros. Up here in the numerator, we have x plus 3 in parentheses and nothing else like it. If you have a factor that doesn't repeat itself in the numerator, you have yourself a 0, and that's what negative 3 is going to be. And what we also have in the numerator is x minus 3. In the denominator, we have 2 of those. So if the multiplicity of a factor in the denominator is greater than the numerator, the denominator is more powerful and you have yourself a vertical asymptote. If they were exactly the same, you'd have a whole. If they were greater in the numerator, you'd have a whole at the x-axis. But that's what we have, a vertical asymptote here. X plus 5 in the denominator, minus 5 is your magic number. That's the only thing that's there. You have a second vertical asymptote. Okay, so let's take a look at our options. F of x has a vertical asymptote at negative 5 because there's a factor of x plus 5 in the denominator and no such factor in the numerator. That is true, so that's not what we want. We are not going to select that. Okay. F of x has a 0 at x equals negative 3 because there is a factor of x plus 3 in the numerator and no such factor in the denominator. That is also true, so that's not the one that we want. F of x has a vertical asymptote at x equals 3 because the multiplicity of the x minus 3 is lower in the numerator than the multiplicity of x minus 3 in the denominator. That is also true. Okay, so be careful with the wording, but it does say multiplicity of the factor x minus 3, so you have a multiplicity of 1, is lower in the numerator than the multiplicity of x minus 3 in the denominator. True statement. F of x has 2 zeros because the numerator x squared minus 9 can be factored. I mean, yeah, it can be factored to that, but this is not a 0 because it's negated by that. So D is the lie. D is the lie, which is funny because D is devil, and the devil is a liar. I hope this helps.